All right, first question, which line is skew to ED? So we have line ED here. And remember what a skew line is a line that doesn't intersect, but it's on a different plane. Okay, so it's not parallel, it's skew instead. And here's the difference. I'd say that JF is parallel to ED. It doesn't intersect ED, but it's on the same plane. It's running in the same direction, so it's parallel. Some examples of some skew lines then would be CG. Okay, CG and ED are not going to intersect. Okay, but they're running in different directions. They're on different planes. That's why we'd say they're skew, not parallel. Some other skew lines we have are BH, AI. We could also say HI and HG. Okay, all those are examples of lines that will not intersect ED, but they don't run in the same direction. They're not on the same plane. Therefore, they're skew. Next question asks, which angle pair are alternate interior angles? Can I have the actual answers down here just because there's several sets of alternate interior angles. We need to pick kind of the right one. And remember what alternate interior angles means is we have angles on alternate sides of the transversal. So in this case, if this is my transversal, one will be on top, one will be on bottom. And then the interior means they'll be between the lines we're dealing with. Okay, so as far as which one of these work, we'll just kind of show you what the answer is. We won't go through all the bad answers. But we could say that 1 and 6 are alternate interior angles because if I have my transversal, 1 and 6 are on alternate sides. One's above, one's below. And as far as the two lines that intersect with our transversal and make 1 and 6, okay, 1 and 6 are both on the interior. They are between the lines, okay, whereas outside the lines would be the exterior. Okay, so that's why those are alternate interior angles. Next question says to determine which type of angles angle 1 and angle 2 are. Okay, let's take a look here. Here's angle 1. Here's angle 2. Now they are both above our transversal. And as far as the other lines that intersect, they're both below those lines. Okay, so in other words, they lie in kind of the same spot on the intersection. We'd say they lie in corresponding places. Therefore, we'd say these are corresponding angles. And again, what that corresponding means is they lie in the same position relative to our intersection. They're both on the lower right. Next problem says to find the measure of angle 1 and angle 2 in our diagram. Okay, this is a great question, a lot of good details going on here. So what I have are a set of parallel lines, AB and DC, and I know they're parallel because they both have the arrow on them. And then two different transversals, AD and BC. And then we're going to have a few different properties happening here because the 80 and the 1 and the angle of 70 degrees and the 2 are two different types of angle pairs. Okay, starting off with the 80 and the 1, notice they're on the same side of the transversal, same side of AD, and also between the parallel lines. So I'd say they are same side interior angles. Now I know that when my lines are parallel, same side interior angles are supplementary. They have to add to 180 degrees. Meaning that if I take 180 minus this 80, angle 1 has to be 100 degrees, okay, to make them supplementary. All right, so when our lines are parallel, same side interior angles are supplementary. Now for the other transversal then, the 70 degrees and the 2, they're on alternate sides of the transversal. Okay, they are alternate interior angles. And we know for them, when the lines are parallel, alternate interior angles are congruent. Okay, that's why we're getting angle 2 here is 70 degrees, the same as this 70 we're given above. Okay, so the property I use, the way I figure out what that missing angle is all going to depend on what type of angle pairs I'm looking at. In this case, same side interior or supplementary, alternate interior are congruent. Okay, bonus question for you here then. Notice angles 1 and 2 are same side interior angles as well. Okay, however, they don't add to 180, they're not supplementary. Well, reason for that is this line AD and this line BC were not given that they're parallel to each other. And in fact, they don't look parallel. It looks like they're going to run into each other if we keep going up. Okay, so my special properties don't apply here, and they're never going to apply when those lines aren't parallel. All right, next question says find the value of x. And we have a triangle that we're given, but the trick with this one isn't to worry about the whole triangle. All we're going to worry about are these parallel lines, which we know are parallel because they have the arrows on them, and this side of the triangle acting as a transversal. Okay, so I have parallel lines and transversal, and then the angle pair they give us here, what this 3x minus 10 is pointing to and where the x plus 40 is located, those are both corresponding angles to each other. Since they're both on the lower left part of the intersection, we'd say they're corresponding. And the thing I know about corresponding angles, when the lines are parallel, corresponding angles are going to be congruent to each other. Okay, so in this case here, we can set these two expressions equal. We can say that 3x minus 10 is equal to x plus 40. And then we can solve the equation for x and figure out what the angles are if we need to. But the big thing with this question is setting up the equation, and I can set these two equal to each other because, again, corresponding angles are equal when the lines are parallel. Okay, running through this then, I'm going to subtract x from both sides to get x by itself. So that gives me that 2x minus 10 is equal to 40. I'm then going to add 10 to both sides. And we get 2x is equal to 50. And then we can divide both sides by 2 and end up with x equals 25. That's where our answer for this one's coming from. All right, next question asks which lines are parallel if the measure of angle 5 plus the measure of angle 6 equals 180. Okay, well, let's figure that out. We've got 5 and 6 on the right here. And we know that when I add them together, I get 180 degrees. So they're supplementary. Now, 5 and 6 are same side interior angles. And we know when same side interior angles are supplementary, the lines are parallel. So the key for this problem is just figuring out which lines will be parallel. Okay, which line is my transversal, and then which are my two parallel lines. Okay, it looks like B here is going to be our transversal. And then the two lines that make up those same side interior angles are lines D and E. And again, since we have same side interior angles supplementary formed by lines D and E, that's how I know that D is parallel to E. Those lines have to be parallel based on this information we're given. Next question, pretty straightforward. Find the measure of angle 1. And angle 1 is an interior angle in a triangle. And since I know the other two interior angles, this one's pretty simple. And the trick is using the triangle angle sum theorem. I know that any triangle I look at, the three angles have to add to 180 for a total. So what I can do then is I can just subtract the other two angles from 180. I can say that angle 1 is equal to 180 minus 100 minus 42, which will give us a 38 degrees for that last angle. Okay, triangle angle sum theorem. Angles of a triangle always add to 180. That's how we're able to figure this one out. In the next question, we have another triangle problem. It says find the value of x. And for this one, they give us an algebraic expression for each of the three angles. And this is going to be another question that utilizes the triangle angle sum theorem. Okay, again, we know that all three angles of a triangle have to add to 180. So I can use that to make an equation. I can add my angles together. I can say that x, the first angle, okay, plus the 2x minus 9, plus the 2x plus 4 is equal to the total. Again, triangles always add to 180, so we can say is equal to 180 degrees. All right. If you can set the problem up, you can probably solve it. Okay, we'll combine like terms. X plus 2x is going to give us a 5x. And then negative 9 plus 4 will be a negative 5 is equal to 180. I'm going to add 5 to both sides of this equation, which will give me a 5x is equal to 185. And then divide both sides by 5, which will give us x equals a 37. Okay, once again, utilizing the triangle angle sum theorem, we know all three angles of a triangle have to add to 180. That's why we can add these all together and set them equal to 180. Next question. For the figure shown below, find the measure of angle 1. And we have a triangle once again. But notice this time angle 1 is an exterior angle of my triangle. Now I have a theorem for exterior angles. It is that any exterior angle in a triangle is equal to the sum of the two opposite interior angles. So in other words, what I can do to find angle 1 here is I can say angle 1 is equal to 60 plus 63. In other words, 123 degrees. Okay, that's kind of the quick way to answer this question here. Now, if I forget that theorem, what I can do instead is just use the regular triangle angle sum theorem. I can take the 180 for the total of a triangle and subtract 60 and 63 to get 57 for this third interior angle. And then from there, between the 57 and the angle 1, I have a linear pair. I know these will add to 180 as well. So if I take 180 minus 57, I'll get that same 123. Okay, so there's a few different ways to work your way through this one and find angle 1. Next question says to use the graph to write an equation of the line. So we're given a line, and we're given a few points on that line. Now, anytime you're talking about graphs of a line, the first thing you want to start off with is the slope. We usually call that m, and the way we'll calculate that is rise over run. The change in the y's, we'll say y2 minus y1 over the change in the x's, x2 minus x1. And filling in the points we have, we can say in either order, y minus y. I'm going to go 4 minus negative 1, so 4 plus 1. All right, over in the same order then, x minus x, we'll say negative 3 minus 3, which will turn into a 5 on top, a 6 on bottom, and since the 6 is negative, we'll just throw a negative out front here. Okay, so there's our slope. And then once we have the slope, we can actually write the equation. Now, there's two different equations we know, slope-intercept, which requires the y-intercept. And I guess I don't see a nice y-intercept value. This might be nice, but we're not sure. And then also there's point slope. Since I have points on this line along with the slope, we'll use the point slope. That formula was our y minus y1 is equal to m times x minus x1. Okay, plugging in what we know to that, we have the m, which is our negative 5/6. And then on the right, we have x minus one of the x coordinates. And I can pick either of these two I want. I'll just go with the smaller one here. So x minus 3. And then on the left, we'll go y minus the y coordinate, which is a negative 1. So we'll say y plus 1. All right, so there's a good equation in point-slope form. Now again, I could have also used this other point. I'd have different numbers here, but it'd be technically the same equation, so that'd be correct as well. Okay, we'll leave this one like this because that's the way the Kahoot answers work out. But on the actual test, pay attention to what form are we looking for. Do I need to solve for y and convert this to slope-intercept form? I'm going to say in this case we don't. Next question says, write the equation of a vertical line through the point 1, 8. Okay, vertical lines, horizontal lines are pretty simple, but they're easy to flip-flop and confuse. So I'm going to draw a picture for this one. So I'm going to make a rough sketch of a graph, and we'll say that 1, 8 is about here, right 1 up 8. And then if we're talking about a vertical line, that's going to be a line going straight up and down. And the key for writing this is by talking about the axis that it intersects. It's a vertical line, but it runs through the x-axis. And it's going to run through at the same point as its x-coordinate. Since the vertical line is not moving left and right at all, it's going to have an x-intercept of 1. So the way I can express this line then is I can just say x equals 1 is my vertical line. Now a little bonus for if I want to do the horizontal line, that's going straight left and right. It's crossing the y-axis at 8. Okay, the y-coordinate for my point, so for my horizontal line, I'd say y equals 8. Okay, it's important that you're able to do both, and again, not confuse and flip-flop them. Next question says to write an equation in slope-intercept form of a line through the point, negative 2, 3, with slope negative 5. Okay, when we have the point and a slope, we'll start off with our point-slope form of the equation. That is the y minus y1 equals m times x minus x1. Okay, where m is the slope and x1, y1 are the x and y coordinates of any point on that line, which in this case we'll use this negative 2, 3. Okay, filling this in then, we have our slope is the negative 5. And then for the x minus x1, we'll go x minus the negative 2, so we'll flip that over to a plus 2. And on the left for the y minus y1, we'll say we have y minus the y coordinate 3. Okay, so we've got our equation written, but notice this one says we want the answer in slope-intercept form. Okay, do pay attention to the form you're looking for come test time. Okay, make sure you don't put the wrong one in. So slope-intercept form is our good old y equals mx plus b. So if I take this point-slope form and solve it for y, that'll be in slope-intercept form. That'll be my y equals mx plus b. So to get that, what I'll do is I'm going to distribute the negative 5 on the right, which will leave me with a y minus 3 is equal to negative 5x minus 10. And then to finish up, I'm going to add 3 to both sides to get the y alone, which will leave me with a y equals negative 5x minus 7 as a final answer. Next question, it asks, are the lines shown in the graph parallel? Okay, so in other words, we want to know, do they have the same slope? So what we need to do first is calculate the slope for both these lines. Okay, first line here, we'll call that line 1. I'm going to find M1 for slope 1. And remember, slope is y minus y. So I'm going to say 5 minus negative 4, or plus 4. All right, over in the same order, x minus x. So we have negative 1 minus 2. So we have a 9 over negative 3, which will reduce down to just a negative 3 for a slope. All right, let's check the slope of the second line, see if we get the same thing. We'll call that M2 for line 2. Same idea, y minus y, so let's go 3 minus negative 4, in other words, 3 plus 4. Okay, over x minus x, negative 3 minus negative 1, so negative 3 plus 1. All right, that's going to be equal to a 7 on top and a negative 2 on bottom. I can throw the negative out front, just call it a negative 7/2. Okay, either way though, these slopes are not the same, so I know eventually these lines will catch up and run into each other. So we'll say no, the lines shown are not parallel. Next question, it asks, are the lines shown in the graph perpendicular? Okay, we know that perpendicular lines have opposite reciprocal slopes. So for this question, what we'll do is we'll find the slope of both lines and then compare them to see if they're opposite reciprocals. So let's do that. We'll start off with line 1 here. We'll say we are calculating M1 for slope 1. And again, slope is y minus y, so we'll go 2 minus negative 4, or 2 plus 4. All right, over in the same order, x minus x, so negative 4 minus 0. Which is going to give us a 6 on top, negative 4 on bottom, and I can pull that negative out front and just reduce this down to a negative 3/2. Okay, let's compare that then to our line 2. We'll say its slope is M2, and again we'll go y minus y, so I'm going to say negative 3 minus 3. All right, over negative 5 minus 4. Okay, which will turn into a negative 6 over negative 9, which reduces to a positive for the negative over negative, and 6 over 9 reduces to a 2/3. Okay, I'm going to say since these slopes are opposite reciprocals, okay, one's negative, one's positive, and if I flip the fraction, I get the same thing. We could say yes, these two lines are parallel. Okay, one trick for you on this one, with the Math Excel, it doesn't word it as they're parallel because they're opposite reciprocals. It words it as they're parallel because the product of the slopes is negative 1. Well, that basically means the same thing as opposite reciprocals. If I take two opposite reciprocals, like 3/2, and I take their product and multiply it by a 2/3, okay, since they're opposite reciprocals, the 3's would cancel, the 2's would cancel. My end result would just be a negative 1. Okay, so really talking about the product of negative 1 is the same thing as saying its slopes are opposite reciprocals. Last question in this Kahoot. Okay, what's the equation of a line perpendicular to this line that goes through this point? Okay, so we have a point that we want our line to go through, something we've done a whole bunch, and we want it to be perpendicular to this line. Okay, when I say I want a line perpendicular to another line, that's just another way of saying what I want the slope to be. Now, the slope in my given line is a negative 2. We can think of that as negative 2 over 1, meaning that my perpendicular slope will be an opposite reciprocal. Instead of negative, it will be positive, and we'll take the 2 over 1, flip it upside down, and say 1/2. Okay, from there we can then fill in our y minus y1 equals m times x minus x1 equation. Okay, our point slope form equation, because I know my slope and I know what I want the point to be. So I'm going to plug that slope in for the m. So we have 1/2, and then times x minus the x coordinate, which would be a 3. And then on the left, y minus the y coordinate, which would be a -2. So in other words, y plus 2. All right, and that's the way the Kahoot has the answers, in just point slope form. Again, come test time, make sure you're double checking and getting in the right form. Okay, solve for the y if you need to, if it's asking for slope intercept form.